Okay, so we're going to have a look at the power distribution, and what from that power distribution we're going to find its raw moments, and then with the raw moments we're going to find the mean and the variance from that formula. Now the raw moments is written like this, it's e x to the r. So r is positive whole numbers 1, 2, 3 all the way up to how many raw moments you want to calculate. Now the lower the number, the more significant it is in the distribution. So for example, if ex to the 1, that is the mean, so that's what we're going to find first, and then what we're going to find next is the variance. Now the variance is ex squared minus mu squared, or otherwise we can write it as ex squared minus e of x squared. So this is our variance. Okay, so first of all we need to find out what the power distribution, what the formula for that is. Now the PDF for the power distribution is beta times x to the beta minus 1, or to the power of beta to the minus 1. Now beta is the value of a parameter and x is the point of interest. So our x is between 0 and 1. So we write that for our support of this PDF. So that's where our x lies. It's between 0 and 1. And the beta is basically a whole number. Sorry, is a positive number, not necessarily a whole number. Beta is a whole number greater than 0. So that's how we do our power distribution. Now next we want to find is what ex to the power of r is. So the formula for this is ex to the r. It's basically the integral. So from the range of this distribution, which is 0 to 1, and then it's the p.d.f, which is our f of x, and then we multiply this by x to the r, and then take the integral with regards to x. So this is going to be our first important calculation in order to find the variance and the expected value. So now for the f of x, I'm just going to plug in this formula here for the power distribution. So our support is from 0 to 1 of the power distribution, so we know that these parameters are correct. F of x is beta x to the power of beta minus 1, and that's multiplied by x to the r dx. Okay, so just need to do a little bit of algebra on this now. So the beta is not concerning our x, so the beta can come out front. So we've got our beta. Integration parameters will remain the same. Now this x to the beta minus 1 and x to the r, we can now combine this. So now we've got x to the r plus beta minus 1 and integrate with regards to x. Okay, so now we're ready to integrate. We can integrate this one straight off. So using the power rule for integration, the minus 1 will disappear because we're increasing by 1. So we've got beta x to the r plus beta. So that's increased this by 1, so we've added 1. And then we need to divide by the new power. So that's r plus beta. And this is calculated from 0 to 1. Okay, so where we see an x, plug in a 1. So multiply by beta for the whole thing. So put a big bracket around everything. So the first one, x is 1. So we've got 1 to the power of r plus beta over r plus beta. So that's when x is 1. And now what we need to do is plug in for when x is 0. So now we're going to subtract 0 to the r plus beta over r plus beta. Okay, now I need to just simplify this off a little bit. So beta to the 1 times 1 to the r plus beta over r plus beta. Now whatever you put 1 to the power of, it will always remain at 1. So that will remain at 1. And then they've got the r plus beta and the r plus beta here. So let's factor that out on the outside. So we've got a 1 here. Let's just tidy that up a little bit. Just put the 1 there now. We've taken the fraction out. Then we're going to subtract. Okay, 0 to the power of something, still going to be 0. So therefore this whole term here disappears. So just put a 0 in there. So now our ex to the r, we're ready to signify what that is. If we multiply all of this by 1, we're just left with what's on the outside. So our solution here for ex to the r, the raw moment, is beta over r plus beta. So that takes care of that. So now I'm going to rub this off the screen, and then we're going to continue now, work out our expected value and our variance. Okay, so our expected value, or our mean, is e of x. In other words, r is value 1, which is pretty simple. We just plug in a 1 for the r here. So we got beta over 1 plus beta. So that's our expected value. So that's our mean. So we can just plug that straight in here now. So e of x equals beta over 1 plus beta. So that's the expected value, or the mean, of the power distribution. That takes care of that. Okay, so let's calculate our variance. Variance of x equals e of x squared minus e of x all squared. So e of x squared, that's just because we're plugging in a 2 for our r. So that's beta over 2 plus beta. And then e of x squared, so now we just subtract this one squared. Beta over 1 plus beta, and all this term is going to be squared. Okay, let's simplify this off. So if you make this into one fraction, so we're left with 2 plus beta and 1 plus beta squared. Obviously this term is squared. And now we just multiply this side with this one, and then this side with this one. So we'll put these together. So now we'll have a beta times 1 plus beta squared. And then this side we've got our minus beta squared times this side, which is 2 plus beta. Okay, let's simplify this off a little bit. We can FOIL this quadratic here. So we'll have a beta. Now 1 plus beta squared, we can do that pretty quickly in our head. That's going to produce that. And then this side, we just multiply out the beta squared with each term in the brackets. So that's minus 2 beta squared. And then minus and a plus. So remember, this will be a minus. So that'll be minus beta cubed. And that's still over the same denominator. Okay. So that looks more like a 13. Let's make that sure it looks like a B. Okay. Multiply this beta inside here, and let's see what we've got. So beta times beta squared, beta cubed. Beta times 2 beta is plus 2 beta squared, and then beta and 1 just gives us a beta. Then subtract 2 beta squared, and this time minus beta cubed, and again let's just simplify this fraction off a little bit. Okay, now we got some things we can cancel. Beta cubed and beta cubed. they will cancel. Our 2 beta squareds plus and minus will cancel, and now we're just left with a beta. So this equals beta over 2 plus beta 1 plus beta squared, and that's our variance. So I'm going to write that in this box over here. So our variance of the power distribution is beta over 2 plus beta 1 plus beta all squared. Okay, and that's our variance using a calculation from our raw moments. So that's our variance, and then that's our expected value. That was the original question, and this is our raw moment calculation. So that gives the answer to our original question. Okay.